The human body evolved in an environment of food uncertainty. For the vast majority of human evolutionary history, food was not constantly available. Meals were not scheduled 3 times daily with snacks in between. Energy came in irregular, sometimes abundant, sometimes scarce supply, contingent on seasons, hunting success, weather, and geography. The Greenlandic Inuit experienced this variability in an extreme form. Successful hunts brought caloric abundance. Failed hunts or severe weather brought genuine scarcity. Surviving that oscillation required a metabolic system capable of switching fluidly between fuel sources, storing energy efficiently, and maintaining function through caloric deficit. This capacity is called metabolic flexibility, the ability to readily oxidize fat for fuel when glucose is scarce, shift to glucose when carbohydrates are available, and produce ketones as a brain fuel during extended fasting. It is, in evolutionary terms, one of the most fundamental features of human metabolism. It is also, in the modern era of constant food availability and carbohydrate-dominant eating, increasingly impaired in much of the population. Metabolic inflexibility shows up as difficulty going more than a few hours without eating without experiencing irritability, cognitive fog, or physical discomfort. It shows up as a blood sugar roller coaster that demands frequent carbohydrate intake to maintain stable energy. It shows up as poor fat oxidation even during aerobic exercise. These are not symptoms of willpower failure, they are physiological consequences of a metabolism never called upon to perform the fuel switching it was built to do. The Greenlandic model suggests that cycles of feast and fasting, even moderate versions, maintain the metabolic machinery that constant feeding allows to atrophy. Research on time-restricted eating, intermittent fasting, and carbohydrate cycling supports this general framework. 12 to 16-hour overnight fasts, practiced consistently, appear sufficient to induce measurable improvements in insulin sensitivity and fat oxidation in previously metabolically inflexible individuals. Periodic longer fasts or fasting mimicking protocols extend these benefits further, inducing autophagy, the cellular housekeeping process that removes damaged proteins and organelles, and reducing inflammatory signaling. The warnings here are specific and important. Fasting protocols are not appropriate for everyone. Individuals with a history of disordered eating, those who are pregnant or breastfeeding, people managing diabetes with insulin or sulfonylureas, and those with certain metabolic conditions require medical supervision before altering eating windows. The goal of metabolic flexibility is not caloric restriction as an end in itself. It is restoration of the adaptive capacity that the body is designed to have and that modern eating patterns have quietly dismantled. The Inuit did not fast by choice. But the metabolic fitness their feast scarcity pattern developed is a model worth learning from.